Okay, so today we're going to talk about files, opening files, closing files, writing to files. I think this is one thing a lot of people wonder about when they first start programming is like, you know, for example, we have auto graders and we have all this AI stuff nowadays. Um, and you always hear like, oh, they take a lot of data, they take a lot of whatever information, but how does this information like get into these programs? Well, there's actually ways of taking a file. So, for example, if you have Python project, let's see, can I draw here? If you have a main Python file, um, you can, put inputs into it. So you can put inputs, um, like as files. So you can have files, and these can be in the form of text files. For example, what if you want to have a Python file that reads, a bunch of numbers and your input file, let's say numbers.txt has a bunch of numbers, 1, 2, 3, 4, 5, and your main Python program or file takes these numbers, line by line and does something to it. Let's say it wants to add every number, or you want to add each number by 1. Let's say you add each number, or I guess let's just say +1 to every number in the text file. And then you can output, you can either output to a new file or, overwrite. So you can rewrite your new thing and have 2, 3, 4, 5, 6, etc. And this is pretty powerful because now you can do things like create images or, create graphs, all this other stuff that you probably didn't realize that you could do before. It's like how do we do this? Because images, for example, and that's what we're going to be working with, there's a lot of different formats, um, but they all stem from the same thing. They're all different files. That we've got different file types for images. They've all got like a specific way that they're written. So for example, in this lab, I think that we use a specific type of file structure, and this file is called a PGM file. And this file, whatever software you use knows basically how to read the file and how to interpret it. But what we're going to do is we're going to try and make a Python program that actually generates a file in this format. So we're going to first have to note, I'm just reading from the lab over here, that we've got one line here in a file. And again, any file, any file that you've got, usually without any extension. There's no file type yet here, but there's lines, you see. So our first line will be the header line. So let's say header. And it seems like every line after that, so however many lines you have, everything after that is going to be the actual image data. Well, I don't know how the data looks like, but we're going to look at it in a second. So basically, if you run a software that wants to read this image, that software, you could actually make one yourself because if you know how to take in an input file, well, what if you had some numbers here? I don't know exactly the format yet, but this top line gives some specifications about what the file is going to look like, and then everything else down here might be, like image data. So you could actually write one, and this is, of course, what other applications do. When you run, for example, Adobe or any software that's able to read PDFs, for example, they have software that knows how to interpret the data in the form of a PDF and then display it. This is just a different type of file. So after that, I guess we've got image, and that just goes on forever. So there's multiple things that we've got in the header, it seems like. So we'll have 4 numbers. You'll have, in the header, got 1, 2, 3, 4. It seems like, we're going to have, a few different things here. So looking at our highlighted stuff, we've got the image type, image width, image height. and then the depth. So, when a program reads this file, it wants to know, how big is the image? What's the width? What's the height? What's the depth? So we're going to need to like give it that in the top line. So, the program will probably read the top line, make some adjustments to, its reading process, and then it'll read the rest of the image. So it seems like, first one's always going to be P2. And then we've got some numbers that we don't know yet. Actually, it looks like we have 255. So at least we know that this is always going to be 255, just reading here. And then all of this yellow stuff, so the actual image here is represented seemingly by pixels. So you've got 3 colors. Well, I guess I don't know if you'd say that these are colors, but basically each line here corresponds with just 1 pixel. So as you can see here, all zeros means, very dark. The all ones, I guess it just corresponds with different shades. So, that's how we're doing this. And since this isn't a color, it's kind of, hard to, I guess, understand, but we're just working with different shades of black and white. So I guess a pixel could have values between 0 and 255, where 255 represents a white color and 0 represents a black. So any mixture of those colors will give you some new type of thing, some type of gray. Okay. So if you have a Mac, it seems like as long as you make this file and you rename it to this, or maybe you could generate the file with this file name and you try and open it up, yeah, I think you should be able to open it up and actually see what the image looks like. If not, there is a site that will let you do it. And let's see. So I guess you can, put in a file, or you can just give the data here. And if you want to, give data like this, as you can see, it's got a header. I think that our header is just 1 line. Seems like this header is 2 lines. So maybe, I don't think this matters. I think that you can put it all on 1 line, but we'll try it out and see. But let's actually look at how we're going to do this. So we're going to have 1 class. This class is going to be the parent class where all of our images are generated. So for example, we have, actually, if we get more context into the actual lab itself, we have to generate different patterns. I think it says 3 different patterns. So let's say that you've got, I don't know what type of patterns we could have, but let's say maybe we wanted, one of our patterns to be checkerboard. This is just white, right? So I don't know. Maybe this is a pattern. And, we need some other stuff. So I don't know. This is kind of what I mean by a pattern. We want to generate this, but how do you do that? Because I guess you could make all different types. Maybe you could make just a diagonal line. But anyways, how we're going to make this work is we're not going to make, just functions that do this. Instead, we're going to make 1 big pattern class. So let's say pattern. This pattern class will have some array. So this array, this will be a 2D list. So it'll have a list here, and then inside, there's some numbers. Inside, there's some numbers. And this array here corresponds to the actual data. Like, what does the pattern look like? And if you remember, each pixel here should be 3 digits. So I guess that's probably why we're going to use a 2D list, and each list inside is going to have 3 digits. So the pattern class will have this information, and then it'll have a function. So it'll have a function to make the image. Make image. And this one will make either image that's I mean, I think it says image.txt, but I guess you could probably just, create it. This function will create a file. Let's say, I think it's .pgm. You can do this. So I guess you want an output file to be created. And you'll make this image by passing in some file name that you want to create it as, and then that's it. And it'll create the image based on the data. However, that's all it's supposed to do. We're going to have some smaller classes or, child classes that will be more specific. So let's say that I wanted to have a checkerboard class. All right, so this is parent class. This checkerboard class is going to, pass in the super class or the parent class so that we can actually start, we can use some of these functionalities here. And then what will it do? This will, you can initialize it. So let's, you're going to have an initialization one here. And of course, I believe that up here, you initialize the super class here. This is the only thing that you have inside of it. It's the only member variable, so it's the only thing that you need to initialize. This initialization function here is going to take in a couple things. So it's going to take in, of course, self, because it's a class function, and then everything else that you need. So for example, what else do you need? Well, looking at the file type, you're probably going to need, because the depth is 255 all the time, and the image type is always P2, you're probably going to need those two only. So maybe you just need width and height. So probably just pass in width and height there. And right, and so that's what you'll use to calculate your pattern. Now let's see. I'm going to try and give an example of this. Oh, hold on. So let's first save this. I'm going to say patterns.py. Well, I think pattern is already a file, so pattern.py. Patterns.py is provided to you, so you can kind of see like what's going on here. But I think that that's given to you. So you can use that as some example, but I think you can't create the same type of pattern. But you'll start by creating your class, the major class. So pattern, and then you'll write your initialization function. And so what do we need? Well, this one's pretty easy. We're just going to have an array here, and we're going to call it data. And this is going to be literally just the raw array that contains all of the pixels inside of it. So let's do that. All right. And then I think that the last thing that we need for this is just a make image. So let's do that. Def make image self file name. And when you want to make a file, you can use this functionality that Python has. I don't know if you've covered it in class, but you can use the open function. So you'll do it like this. So you'll do with open, and you're going to pass in the file name. So file name, maybe this is a file, maybe it's not a file. However, when you do open, it's just going to create a new one if it's not already there. So let's say file name, and then we want to pass in the argument. So it says open has a couple different arguments. First the name, and then the mode. So we don't need buffering, but the mode. So we want write. So W means write, because we want to like make changes, right? We want to create a file using the .pgm extension. And then you can just say as, and then you can just write file. Let's do that. Where is this? Okay. And then I think that you can just, create the grid. So for example, you're going to do this. So within this file, you're going to start by saying, okay, create header. So this you can do by printing it out. So you can print, and then I'm not going to actually write it all out. But for example, you could do this. And let's start. How does the header look like? Well, it starts with P2. And then it's going to need some argument. It's going to need width, height. So there's going to be width, there's going to be height, there's going to be 255. And you have to figure out how to put these inside here. And then I believe that you format this by saying file, it's file. And this is going to take this print statement, or I guess this print, not the print statement, but the string, and it's going to output it into this file. So when you actually run this, you're going to get a new file created somewhere, and it's going to, show up. This is going to show up, and whatever's inside of these, they'll be formatted because you're using a formatted string. And then for the rest of the grid here, you'll have to create grid. And this can be done in, if you just look at how it's designed. So you've got, let's say, you have one big grid here, which is the outer grid. And then inside of this, you've got all of these. And each of these might be like 1, 1, 1. I think they should have commas, but 2, 2, 2, whatever the value is, right? And on and on and on. So the way that you can like easily output this is you'll want to go through each individual array here, and you'll want to print it out. So we'll do it like this. We'll go like print, and then actually no, we need to loop through it, right? So for row and how do we access this array? This is the data array, right? So this is the data array, and we have it up here. So we'll just do self.data. And then we want to go through every single column, and we want to output it in a way that looks like this: 1, 1, 1, right? So we don't want any commas. We don't want any of that stuff. So we're gonna separate each one by a white space. And we can do that. So for each one inside of row, right? So double for loop. Now we're accessing each of these individual elements. So for each element in the column, we're just going to print that value, literally just a number. That's fine. And you're going to specifically ask it to end with a white space because we want to separate it with a white space. And then again, file equals file. And I think that if you use a different file name, like if you put file here, I think that you just set it like that. So that's the naming, but I think it's easier like this. And then what do we need to do? Well, we need to print a new line, right? So I think just a single between every row, we need to do that. So let's do it here. So, printing the print statement itself does a new line. So all we need to do is just put this argument, and they should print a new line. So this is all. This is it. This is basically what you wanted to. You can figure out how to get these arguments in here, and I'll show you kind of what I mean by this. You're going to, create these child classes, and I'll show you in a sec. So let's do that. I'm not going to actually make a pattern, but I can also, I'll show you how this will work. Let's say, why don't I just like hard code these for now? Maybe I can actually try and generate this image. This should be fine. Why don't we write a main function that'll generate some type of pattern so we can actually see how this works. So we're going to create a simple pattern. Or let's say I just want to create a file that's just all zeros. Let's do that. I'm going to make an array that's 512 by 512 because that's how big I want my image to be. So I'm going to say data equals, I'm going to make a 2D array. I'm going to use list comprehension. So 0 for I in range 512. And then I'm going to do this 512 times. So for j in range 512. So that should create a 512 by 512 list of all zeros. And then I'm going to, call this make image function by actually creating a pattern object. Let's do that. We've got, let's say, my pattern. Probably shouldn't do that. My pattern equals pattern, and I'm going to pass in data, right? Because the data is there. So my pattern data, and then all I'm going to do is just call that function that we just wrote on it. Equals make, no, I think I just do it like this. Make image, and then I'm going to pass in what? Well, it says file name, so let's pass in a file name. So let's say all zeros, and then what image do I want? Well, I think I could create dot txt, it says, but I'm just going to create a dot pgm anyways. You might not be able to open this if you're on Windows, but if you, take the file and then just submit it into this viewer, it'll still work. So let's just write it anyways. Test. Okay. And then, of course, let's say that if we run this file, it actually goes that. And then, all right, so that should be it for now. We haven't finished everything, but this is like the overarching thing that we want. So remember, you're going to have to pass in these arguments, but we'll get to that in a sec. Let's try this. I'm going to see if I can actually run this now and see if it generates us an image. So I'm going to run this Python file in the command or in the PowerShell. So I'm going to go to this. I'm going to go to this directory. So let's go there. So I need to go to the desktop. I need to go to my COP3502 folder, and let's make sure that we're in the right place by doing ls, excuse me. So we see I've already got some stuff here, but I'm in pattern.py, so that's what I want to have. So let's try and run this file. Let's see what happens. So Python 3 pattern.py, and hopefully we'll see a new image. I don't think anything's going to print, but let's just see if this actually works. Okay, so no errors, so I assume that means that it works. So let's actually see what's inside of our folder now. We've got all zeros.pgm. So let's try and open that up and see. Let's see what we've got. All zeros.pgm. All right, so we've got this big text file here that we created, using a Python function. It's got the header line. Looks pretty good. It's got the file, the image type, the width, the height, and the depth. And then, of course, we said we wanted a 512 by 512 grid. So we've got hopefully 512. Maybe if I scroll all the way down, I can see. Okay, well, I've got 513, but of course, there's a header line, so that means that we did this right. That's great, and of course, if I did the same thing with ones, we can actually just verify that it actually works as you expect. What if I say I want 20? I want to create a bunch of 20s. Well, let's run it and let's see if it changes. Because since we're using the same name, it should overwrite the old file. So you don't have to keep changing the names. Let's do python3.pattern. Maybe I'll just open this up so you can actually see if it changes as we run this. Let me go here. Maybe it'll ask me to reload it because I think that when you overwrite stuff, Notepad doesn't like that. I don't know why this isn't. Okay, let's see. Says this file has been modified by another program. Of course, that program is Python. That just changed it, but let's click yes. And now we have a bunch of 20. So that's great. We've got thousands of 20s, and this isn't a very interesting pattern. This is just like an entire thing full of a gray, and I don't know, we can try and see if it works if we input this here. I don't think I can open this natively, but let's try this. It's not all zeros anymore, but it's 20s. So it's all pretty dark. And I think if we do the same thing, but let's see, where is it? We do the same thing with a bunch of like, I don't know, 230s, it'll probably be a lot brighter. So let's see if this works. So run it, got reloaded. Okay, let's put it back in. And now it's a bunch of grays. So this is how it works essentially. Now you're gonna have to actually, figure out how to make a more interesting thing than all of the same color, right? You're gonna need to actually think about, how do I make a pattern? Well, as I was kind of going through here, you're gonna make, for example, checkerboard. I'm not gonna actually make checkerboard, but I'll just kind of show you, the steps for making a child class. For this, you're just going to want to make your new pattern. So let's say second pattern. You can name this whatever you want. And of course, we want this to inherit all of this functionality. All right, we want it to inherit all this functionality. So you don't really need to keep creating. You don't need to keep copy pasting this make image function, right? So let's think. Well, when you initialize this child class, you're still going to have to initialize it. But if you remember, we're going to want to use that super function. So let's say that you want to create a new pattern and all you do is pass in the width and the height, right? So I think those are the two things you need, width, height. And then, so there's something in here that creates data equals something. You make your data here. Let's say that it was that thing, one, or I don't know. I think you have to do it like this. Um, yeah. I don't know if it's width or height. I think it might be a height here. So again, this isn't going to create a very interesting thing, but this will create something, some type of data. This will probably create a very black image, but we've got that. And now all we need to do is just call our image. So or just call our parent function. So we use the super, and then we do init, and then so what do we need to pass in when you create it? Well, you need to pass in the data. So we're going to pass in the data, and now you're done. So now when you call this one in your main function, you can use the dot make image function, create a file, and it'll create that specific one based on whatever pattern you made here. So make your pattern here. And I don't know if there's any specific ways that you can do. You can literally make whatever you want. So whatever you feel like doing is what you can do. And I think that there's like some examples here. Yeah. Yeah, so there's data here. So you could technically just copy this data, put it into a PGM, or you could write a loop or something that creates this type of array, and it'll do that, you know. So you can design this however you want, but that's really the overarching structure that you want to follow. You're gonna pass in file name. You don't have to put .pgm, but I would just suggest doing it because in reality, I don't see the point of doing .txt other than the fact that if you're just using Windows, you can open it. But if you have Notepad++, you should be able to open up any type of file that has data that's readable and then test it. Um, yeah, and so then you just submit all of your stuff inside of this one Python file, and then you're done. And then you just submit the images. But since it needs to be width and height needs to be greater than or equal to 100, you need to make sure that you keep that in mind. Try and make something more interesting than what I've made, but also, you know, don't worry about like, you can use whatever you want, but you can be as creative or as uncreative as you want, but there's a file here that I think is provided for you guys that you can see kind of what I mean by how you would do that. And I think they're using a pattern array, but you can use data or whatever you want. So that's really all I've got. That's the main thing that you want to look at. And I don't know if anyone has questions, but that should give you mostly everything that you need.